Okay, we just worked through this problem. We came up with the equation that we want to solve, and we're going to use Newton method to do it. Just reading over my code, I noticed that I often do this, by the way, but Sage has a built-in function called n, and I'm redefining it. So I want to just change this code a little bit, and instead of using n, I'm going to use nm for Newton's method. All right? So let's open up Sage first. I'll correct my notes as well, by the way. Let me just launch Sage. I'm at the terminal. Just type in Sage. It's going to launch the application. I'm going to reset. And then I'm going to type this function in over here. And the function is actually this thing solved for 0. I'm just doing copy paste, by the way. The next thing I want to do Newton's method, and I'm going to copy paste, but I will change the name of the function. Instead of n, I'm going to call it nm. And I probably should do this in the future as well, by the way. Excuse me. All right. And I don't believe there's a built-in function mn. By the way, Sage has a function called n, and like if I put down like pi, and then put down 100. All right, that's not 100 digits, by the way. If I wanted 100 digits, let me do that for you. A little confusing, isn't it? There's my 100 digits. Let me just clear the screen again. All right, and again, I want to tell you that we did define a function nm. Let me put that down for you. And let's see what it looks like. That's what it looks like there. Now, I don't need to know that, but what I need to do is start using this to generate new guesses. I'm going to put initial guess down of 2.0. And then what we're going to do is I'm going to get another guess by using this guess, using Newton's method. And that's going to be Newton's method. Now when I put the x down, it's going to treat x as if it's 2.0. I want to display the x, but I'm going to use numerical approximation just to force it to give me a decimal. All right? And I get this over here. Now I want to keep repeating this until there's no change. So up arrow. Again, there's certainly a change there, clearly. Certainly a change there, clearly. All right, it seems like it's narrowing down to something, but I'm looking at the end digits now, not the beginning. Still changing, slightly. Looks like it didn't change there. Let me just do one more. No change. All right, so what I want to do now is, make sure you understand this stuff is written down for you. What I want to do is now find out what the A is. And the way to do that, I need to solve an equation. Now, you may wonder what equation I'm solving. I'm actually solving this equation over here. Log base 10 of x equals 10 to the x minus a. But again, what I want to claim over here, when I type in x, it gives me that really crazy looking number. Let me do x approximate though. Whoops, made a mistake there. I get that number over there, okay? So what I want to do is I want to go back and solve the equation for a. Oh, I got to define a first. Sorry about that. And again, you probably know what's going to happen now when I do this. There's going to be an error. I need to correct the error. It's those tick marks. They're using quotes. I need ticks. All right. Let's type this in. And again, s is a placeholder. It's going to hold the value of s. All right, solve the equation. Let me just say what s looks like. It looks like this over here. And if you want to access it, it's actually a matrix over here. So if I do S0, hit return, it gives me the first entry there. Now if I want the right-hand side, it's going to be S0 dot right-hand side. And if I want to approximate that number, whoops, I made a mistake there. If I want to approximate that right-hand side, I use a dot n. And that's the number I get over there. All right? So that's the number we were looking for, which is 2.234158, yada, yada, yada. All right, we found the number. All right, so I want to put out in the graph. What I graphed was, that's the A, by the way. I graphed out both y equals 10 to the x minus a. Again, the a is that 2.3 number. Get this number right over here. All right, And also type that log base 10 of x. They intersect. Where they intersect? When x is about 1.37. Let me show you where that's written over here. That's the number right over here. It's approximately that number. All right? And that's it. Thank you very much for paying attention.